Welcome back, everyone. We are on our last video for the triangle segments unit, and this video is about the triangle inequality theorem. So let's just think about what we know about triangles and inequalities. So we know triangles have three sides, and if you forgot, inequalities means a greater than or a less than symbol. Okay, so in a second we're going to have a rule that talks about something with triangles and less than and greater than. So what this is about is telling us that we just can't go grabbing any three numbers in the world that we want and making a triangle, because a triangle has three sides, right? So we can't just, let's say, grab the numbers 2, 3, and 8 out of the air and say, hey, make a triangle out of 2, 3, and 8, and it will work. There's rules about how long the sides have to be in order for the triangle to work, and here's why. So what I'm going to do is use the letter or the number 8 because the 8 is the biggest one. So I'm going to come down here and I'm going to draw a segment that's 8 long. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this bottom is 8 units long. Now if I try to make one side that's 2, so let's say I come here and this is 2, and then I come over here and try to make 3, as you can see, they're not going to close this hole right here, and there's going to be a gap because 2 and 3 aren't big enough. And you can even check down here, so if I were to draw here 1, 2, so this is 2 long and this is 3 long, there's no way that we could possibly pick 2 and 3 as the other sides with 8. So we got to go bigger. We got to think of some bigger sides here. So let's think of maybe increasing the 2, since that's the smaller side. Let's up it to 5. So let's try 5, 3, and 8. So we're going to keep the 8 on the bottom again. So 1, 2, 3, 4, 5, 6, 7, 8. And then again you have your 3 here and your 5 here. Okay, now here's the problem with the 3 and the 8. If I were to bring them down here and have them along the same side as the 8, I'm going to go 1, 2, 3, and then with the 5, I'm going to go 1, 2, 3, 4, 5. So the 3 and the 5 are equal to the 8, but as you start to bring that up, this orange side up so it has an angle, that 3 and the 5 are going to slowly create a gap here. So these two numbers have to be bigger than 8 when you add them together. And that's what the triangle inequality theorem is. The triangle inequality theorem states that you must have the two smaller sides, when you add them together, it has to be greater than the biggest side. So I'm going to call that big S. So the two small sides, when you add them together, has to be bigger than the bigger side. So for example, when we did the first one, it was 2, 3, and 8. So if you add 2 plus 3, because those are the smaller sides, greater than 8, 5 is not greater than 8. So 5, 2, 3, and 8 are not going to create a triangle. Same thing here. If we went with the second example, 5 plus 3 is greater than 8, that doesn't work either, because 8 is not greater than 8. It's equal to 8. Can't be equal. Not going to work. So let's take a look at some examples that you might see. Let's say that we had, let's try 15, 10, and 12, because I don't want you to think that it always goes in the correct order. So you want to pick out what's your biggest side. Your biggest side is 15. So 15 is going to be at the end. 10 plus 12 has to be greater than 15. 22 is greater than 15, so these three sides will work. So yes, these three sides will make a triangle. Or well, what if you have sides that are all the same? So let's say you had 8, 8, 8. Well, there is no big side, right? They're all the same. Well, we should know that this is an equilateral triangle and it's going to work. But just to prove it, you can pick any of them. I mean, they're all the same. So we can go 8 plus 8 greater than 8. True, because 16 is greater than 8. So this works. All right, another example you may come across would be something that is maybe 5, 2, and 5. So we know here that this is going to be isosceles because we have the two 5s. So you would pick one of them, doesn't matter, and that would be the big one, and you would just add the other two. 2 plus 5 is greater than 5. Yep, that works. So we're good to go. So those are the only interesting situations where you would have to check. All right, the last example we're going to go through is what happens if you have, let's say they give you two sides, 6, 11, and they want you to know what could possibly be that third side. What are our options? So you could think to yourself, well, how do I know what the biggest side is? What if 11's the biggest side? What if my question mark's the biggest side? I don't know. So we're going to find a range. So we're going to call this x our missing side, and we're going to say first that the x is the biggest side. So we're going to go 6 plus 11 has to be greater than x. Remember, we're saying first that x is our biggest side. So that means x, or 17, has to be greater than x, and if we flip that around to make more sense and put the x first, it'll be x is less than 17. So x has to be less than 17 in order for this to work. Now the second option is, what if 11 is the biggest side? So if 11 is the biggest side, then you would set up the equation as 6 plus x, because x would be the smaller side. 6 plus x is greater than 11, because again we're saying 11 is the big guy this time. So now if I solve for x, I would subtract 6, and I would get x is greater than 5. So what this is telling me is that I possibly can have values that are less than 17 but greater than 5. Now I'm going to throw it back. Do you remember back in the day when we graphed things like this? And we would go on a number line, you put 0, dot, 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 whatever, and we get 5, dot, 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 whatever, all the way to 17. So what this is telling us is that our possible answers could be greater than 5 but less than 17. So right in here are all the possible values we could have. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All of those are possible for x. Okay, just trying to show you an option as to what your problems could be like. Okay, I'm going to give you one more just to try. I'm going to write it down and give you a second to think about it if you want to work it out on your own. So you have 12 and 9, and try to find out what is that missing side. Alright, even if you didn't have some time, you can hit pause if you want to. But first, let's check and see if the x is the biggest side. So first you would add 12 and 9 together, and that would be 21. So if we reverse that around to go the correct way, x will be less than 21. Now what if 9 is the biggest side? So now, I'm sorry, not 9, 12 is the biggest side. If 12 is the biggest side, I'm going to put 12 at the end, and I'm going to go 9 plus x here. So I'll subtract 9 from both sides and get x is greater than 3. So my options here, put a 3 here, 21 over here, is that my range of values for that third side have to be between 3 and 21.